Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present our sensor project. First of all, I'd like to introduce our members, Aimar Afra, Muhammad Arqia, Muhammad Zidan Aghazi, and Vytis Rabbani Rex. Our project focuses on developing a simple method to determine the speed of water by measuring the force exerted on a load cell. The proposed system utilizes a load cell sensor to detect the applied force via microcontroller. Then the microcontroller reads the sensor data and a mathematical relationship between the force and velocity to compute the water speed.
Okay, so this sensor measures water flow by measuring the force that exerts the drag mass. The drag mass then twists and produces twisting force that will be processed by the load cell. This process translates water flow into weight, which is measured by the load cell. This system can be applied into many things that can benefit from large-scale industries to houses. It can be implemented into water hoses and water pipes to measure the flow of water that passes through the sensor. Applying load cell into pipes can also offer a few benefits, such as water flow monitoring, leak detection, and efficient water management. Considering the cheaper price of load cell compared to flow meter, it might be more cost efficient.
As we can see here, the sensor is moved by a stepper in the calibrating device. Here, we also can see the sensor has a limit switch. When the limit switch is pressed, the sensor will start to read the force exerted to it. And then when the limit switch is pressed for the second time in one cycle, the sensor will stop reading the force value. This process repeats many times.
Okay, so from the experiment, we acquired the data, and as you can see, the data is linear with little error in it, and the error is around 3% plus or minus, and the error itself has an uncertainty of 5%, so it could be plus 8%, or well, the range is around plus or minus 8% of error, but the average error is around 3%. So I'm able to say that is actually 3%, and the 8% is just an uncertainty.